Yeah, welcome to Easy Learning Maths 112 tutorial class, lesson 2. In this, we are treating topic. Our topic is laws of indices. Laws of indices. And we are in lesson 2. Lesson 2. Please, for you to understand this topic properly, you needed to follow us through our lesson 1, which we have done. You can get our lesson 1 through our YouTube playlist. You search for lesson 1. You go through lesson 1 for you to understand this lesson 2. Okay, if you are meeting us in lesson 2. So, we are dealing with multiplication law revision, multiplication law of indices. Law of indices. And we say that a raised to power n times a raised to power m is equal to a raised to power n plus m. That's our revision. In this case, we say that this is constant. That's what we say in our previous days. But what will bring us here is for us to learn. What brings us back to this is for us to learn that a raised to power n plus m can be written as a raised to power n times a raised to power m. That means returning back of this. Therefore, if I have 2 raised to power 2x plus 4, this simply means the same as 2 raised to power 2x times 2 raised to power 4. If I have 2 raised to power minus x minus y, simply mean 2 raised to power minus x times 2 raised to power minus y. This means I'm writing it in a span form, this in a conc form. This is a span form, this in a conc form. So when I'm doing this, means that I'm writing this in a span form. So that's what we are learning, that's what brings us back today, because we have learned this before. We are here to see that we can bring this back, bring it like this. So now, assuming that this is also applicable to 3 or 4 times of this, that means this times a raised to power m times a raised to power what k, giving us a raised to power n plus what m plus what k, which we learned before. So we can also say that a raised to power what n plus m plus k is simply mean a raised to power n times what a raised to power m times a raised to power k. Example, if I have 2 raised to power x plus y plus 4. This simply means 2 raised to power x times 2 raised to power y times 2 raised to power 4. So I can write this way and I can return it back. That's what brings us to this. Then now let us go to division law. Before we can go to division law, let's see another way we can solve this, and as an example for this, for us to get properly of this. Let us do this so that we can get this. Let us say we have 2 raised to power x times 3 raised to power y times 2 raised to power 2x times 3 raised to power minus 4y, and they say we should simplify it. Then simplify, we're simplifying, we're to simplify this. For us to simplify this, we see that all of them are multiplying themselves. And some of them are in different base, some are in the same base. Looking at this, to simplify this, we see that all of them are multiplying themselves. That means they satisfy the one condition of the indices. And some of them are of the same base and some are not the same. So we can now bring those ones that are of the same base, which is this times what this together, for you to understand it properly, times 3 raised to power y times what 3 raised to power minus 4y. Somebody will say, how? You remember that a times b is ab, meaning that 3 times 4 is 12. And the 4 times 3 is also what? 12. Are you get what I'm saying? So, in respect to the direction, the position is immaterial in multiplication. Position is immaterial in multiplication. That's what we are learning now. Let's say I have 2 times 3 is equals to what? 6. I have 3 times 2 is also what? 6. So in respect where it is what? Immaterial. So now let's go back to what we are doing. Looking at this, I have this here and I have this and this here. I have to bring it together for you to understand. This and this, I have to bring it together. So now I have this to be what? 2 raised to the power x plus what? 2x. I'm adding their power now. They are multiplying together and they are of the same base. Are you getting what I'm saying here? Then times 3 raised to the power y plus minus 4y. And this will give me 2 raised to the power 3x times 3 raised to the power y minus 4y. And this will leave us with what? 2 raised to the power 3x times 3 raised to the power minus 3y. How did I get 3y? Remember what we said. This means that I'm owing 4y. I have a y to pay. I'm owing 4y and I have a y to pay. So if I owe somebody 4y and I pay a y to him, I'm still owing him 3y. And that's why you see minus 3y. Minus indicate that I'm still owing. And that's my answer. I will leave this way. I can't add this and this because they are of the same, of the different base. You look at this base to this base 3. I can't add their power because they are of different base. And despite they are multiplying themselves, but they didn't satisfy the condition that they must be of the same base. But they satisfy the condition that they are multiplying themselves, but they are of different base. So I can't add their power. So anytime things appear like that, you will leave it that way. Are you getting what I'm saying? So don't ever try to do this by saying, I add the power. Why they are of this different base, but they are multiplying themselves? It's a mathematical taboo to do that. It's a law. Then now, let us go to what? Division law of indices. Division law. Division law of indices. Division law of indices. That's where we are. Division law of indices. That's where we are. We said, this man said, this law said that A divided by A raised to power n simply means what? A raised to power n minus what? M. Look at this. Get this right. This man said that A raised to power n divided by A raised to power m is equals to A raised to power n minus what? M. For me to apply this law, 3 things I'm going to learn from this law. This man is constant. This minus is constant. This minus in this formula is what? Constant. Why n, m, a is a variable. This man can take power of 6. This one can take base 2. This one can take minus x. This one can take base 3. That doesn't concern me. That's not my own concern. My own concern is whatever they take, this man is constant. Then now look at it. There's 2 conditions for me to apply this law. For me to do this, there's 2 conditions that I must satisfy. What's that condition? They must be of the same base. Look at this, base A. And they must be dividing themselves. The 2 conditions, they must be of the same base and they must be dividing themselves. If they are not dividing themselves, I can't do this. Assuming that they are of the same base, base 3, and they are not dividing themselves, will I do this? No, I will not do this. Then, assuming that they are dividing themselves, but of different base, base 2, base 3, I will not do this. So for me to do this, they must be dividing themselves. They must be of the same base. And this formula can be stated this way. A raised to power n divided by what? A raised to power m. And it simply means what? A raised to power n minus what? M. That's another way I can say this formula. This and this are what the same. Then I can, for example, I have 2 raised to power 2y divided by 2 raised to power minus raised to power 3y example. This simply means that 2 raised to power 2y, that's the first, which is my what? N. In this case, my n now, which is what? 2y. Then here, 3y is my n. Then my minus, which is constant, will be there. waiting for 3y to appear. And this will give me the answer to the what? 2 raised to power. This will give me 2 raised to power minus y. How did I get minus y? Who is one of these minus? 3y. Who is one of these plus here? 2y. Means that I'm owing 3y. I have 2y to pay. I pay 2y against 3y I'm owing. I'm still owing y, which is minus y. And that's the answer for this example. Let us continue for more example. Let's continue for more example by clearing this, since we have digits. Let us do more example for us to. Let us do more example. Example, I have actually 2 raised to power minus 2y divided by 2 raised to power minus 3y. This will simply mean 2 raised to power minus 2y minus, which is the constant in my formula, in my format is a constant, minus 3y. In this case, in my format, this m have turned to minus 2y, and this m have turned to minus 3y. That doesn't concern me. My constant, which is minus y, minus is there, which is constant. And this will give me minus times minus, which we have already treated, will give me plus. This becomes plus 3y. Minus times minus, which we said minus times minus, the answer is plus. So minus times minus, the answer is plus, which we can say minus 2 times minus 2 give me what? 4. Then now, looking at this, this will be equals to what? 2. I'm owing 2y. This means I'm owing 2y. I have 3y to pay. And when I pay, they will give me a balance of y. I think you get me right. This means I'm owing 2y. And I have plus 3y, which is belong to me to pay. And when I pay, they will balance me y, which is my answer become 2 raised to power y. Then let us look at this. Let us look at this. We'll call it 0 law. Let us look at this. We'll call it 0 law. When I have a raised to power n divided by a raised to power m raised to power n is equals to 1. A raised to power n divided by a raised to power n. The answer is 1. Somebody will ask me how? How is it 1? This man cancel this man, the answer is what? 1. I told you that anything you write is multiplied by 1. This a is multiplied by 1. When it goes, you leave 1. This man is multiplied by 1. When it goes, you leave 1. 1 divide 1, the answer is 1. An example, let us see. We have this. How? Somebody say how. We look at this. A raised to power n over a raised to power what? N is equals to a raised to power n minus n. And this will give me what? A raised to power what? 0. And the answer is what? 1. This divided by this is what? 1. And this a raised to power n divided by a raised to power n, using our formula, using our format, will give me a raised to power what? N minus n, which give me a raised to power 0, and a raised to power 0 is what? 1. So what are we achieving on this? We achieve that anything raised to power 1, anytime raised to power 1, to power 0, to power 0, the answer is what? 1. If I have y raised to power 0, the answer is 1. If I have 2 plus xy raised to power 0, the answer is 1. If I have, if I have 20 raised to power 0, the answer is 1. If I have x plus 3y all raised to power 0, the answer is 1. If I have n plus m raised to power 0, the answer is 1. So what are we going to achieve here from this? What this man is trying to give us here is that we can use any base raised to power 1 to represent 1. Any base raised to power 1, we use it to represent 1. So I can remove 1 and put any term raised to power 0. I can remove 1 and put any term raised to power 0. If I write this 1 like this, another way I can write 1 is to say 2 raised to power 0. I have written 1. Another way I can write 1 is to say 3 raised to power 0. I have written 1. Another way I can write 1 is y raised to power 0. I have written 1 in indices. So anything raised to power 0 represents 1 in indices. So another way I can write x, I can write 1 is what? X raised to power 0. So anything raised to power 0 represents 1. For instance, if I have now 2x squared plus 2 raised to power x equals to 1. I can simply write it 2x raised to power 2 plus 2 raised to power x equals to 2 raised to power 0. I've removed this 0, this 1, put 2 raised to power 0. And by doing so, I have not changed anything here, but I use application of the indices law of what? Division. We said anything raised to power 0 is what? 1. Yeah. In this case, we have seen another way we can write 1 in indices. We have seen another way we can write 1 in this is by raising any base to power 0. We have written 1. Then let us look at what we call power law of indices. Power law of indices. Power law of indices. Power law of indices. The one we deal with is what we call division law. This is division law of indices. This is called division law of indices. We are treating the power law of indices. What's the power law of indices said? He said that a raised to power n or raised to power m can be given as what? A raised to power what? N times what? M. And it can be given as what? A raised to power m times what? N. Remember, this can dance this way, this can dance this way. It's a material deposition. And this can be written as a raised to power m or raised to power n. What am I saying actually? This law is trying to tell us that what? A raised to power n or raised to power m can be written as what? A raised to power m or raised to power what? N. That's what this law is trying to let us know. For instance, example, let us see that if I have 4 raised to power x, I can simply write it this way: 2 raised to power 2 is 4 or raised to power x. 4 raised to power x. I can reduce this base to the lowest base. By reducing it to the lowest base, what will I raise to give me 4? I say 2 raised to power 2 will give me 4. I've reduced it. The 2 is the lowest base of this man. And this will give me 2 raised to power 2 times what? X. And this will give me 2 raised to power 2x. And this will give me 2 raised to power x times 2. And this will give me 2 raised to power x or raised to power 2. So another way I can write this is this, or what it is. So when I see the power law, what we achieved in the power law. And we're going to use this power law in subsequent in lesson 3 to simplify indices equation. Then we will come to this, which gave me this. 27 raised to power y can be written as 3 raised to power 3 will give me what? 27 or raised to power y. And this will give me what? 3 raised to power 3 times what? Y. And this will give me 3 raised to power 3y. And this 3 raised to power 3y can be written as 3 raised to power y or raised to power what? 3. That's our law. Okay. This raised to power this can be changed to this. That's the power law. And these have converted. And we have to put this in memory that this can be changed to this. That's what we needed to know. This is what we needed to put in our memory. That a raised to power n or raised to power m can be written as a raised to power m or raised to power n. That's what we needed to put in our memory. Then now, let us go into indices equation. Let us go into indices equation. What do you mean by indices equation? The equation of indices. Indices equation. Let us treat indices equation. Indices equation. We are not through with the indices law. Remember, we are not through with the indices law. But we want to use these three laws I have what deal with now to specifically treat a case which we are going to meet after this indices equation. We want to use these three laws we have what settled now to treat a case in the next lesson. Then let us look at this indices equation. We'll call it what? Indices equation. Indicial equation. Indicial what? Indices equation. Let's say indices equation. This is equation. Equation of indices, or I call it indicial equation. This indices equation has, before we go into that, what do we mean by equation? If I have x raised to power 2 plus 2 raised to power y, this is indices expression. This is what? Indices expression. Another way, if I have 2 raised to power 2y plus 4 times 3 raised to power y, this indices expression. Meaning, and what we have been dealing since here is indices what? Expression. Then what do we call indices equation? If I have this x raised to power 2 plus 2 raised to power y, this is indices expression, but immediately I say equal to 0. Or we say this raised to power this plus what? 2 raised to power y equals to 4 or 5. I equate it to any number, it becomes what? Indices equation. When I have indices expression equal to any value, whether 0, whether I made it equal to appear, it becomes indices equation. Immediately that appear, it became what? Indices what? Equation. So this is indices expression, this is indices equation. This is indices expression, this is indices equation. So let us go into indices equation properly. Let us go into indices equation properly. We have no what we mean by indices equation. Let us go to indices equation. There's two laws in this indices equation. The laws of indices equation. The laws of indices equation. This is what we want to deal now. The laws of indices equation. It has two laws. One, this law said, if we can make the both sides of the equation to have the same base, both sides of the equation to have the same base, that automatically their power is the same. If we can make the both sides of the equation to have the same base, automatically their power is the same. For instance, I have 2 raised to power x equals to what? 8. And I'm asked to find x. What is it there? 2 raised to power x equals to 8. And I'm asked to find what? X. Looking at this is indices equation, which we say this is indices equation because this is indices equal to a value. Are you get what I'm saying now? This is indices equation. And in this law, the first law of indices equation says that if we can make the both sides of the equation to have the same base, that automatically their power is what? The same. From here, I can say that 2 raised to power x is equals to what? 2 raised to power what? 3. I have not changed anything. Rather, I'm trying to make this to have the same base with this one. And I find out that 2 raised to power 3 will give me 8. 2 raised to power 3, 2 raised to power 3 simply made 2 times what? 2. And that gives me what? 8. By so doing, I have raised this to have the base 2. And doing this, I have made this and this to have the same base. Base 2, base 2. I have made them to have the same base. I'll be able to make them to have the same base. Automatically, their what? Power is equal to this. We say, if we can make them to have the same base, automatically their power is equal. Look at their power is what? Equal. So in this equation, the first law of indices equation said, if we can make the both sides of the equation to have the same base, that automatically their power is what? Equal. So I'll be able to make these two, this side to have the same base, automatically their power is equal. And remember, making them to have the same base does not imply that you will change what is given to. Look at this. I make this to have the same base, but this does not imply that I change this value. This is the same thing as this. That's the condition. Making them to have the same base doesn't imply that you will what? Change exactly what they give you to what? Solve. Making them to have the same basis. Think think what you can make, what you can raise from base 2, the power of, using base 2 to raise the power to give you 8. And I see this as this, and that gives us what answer. Another example, I have 27 equals to y equals to 3 raised to power y. They said find y. Looking at this is indices equation. This is indices equation. And since it's indices equation, like I said, what this can be written as 3y equals to 27. And I have 3y equals to 3 raised to power 3 will give me 27. How? Like I said, 3 raised to power 3 is equals to 3 times 3 times 3. And that gives me 27. By so doing, I have made this to have the same base. Base 3. Automatically, y is equals to what? 3. I cannot say y is equals to what? 3. That's what indices equation is telling us. Another example, which I can treat now, I have 2 raised to power 2x plus 4 equals to 8. They said find x. You look at this, I cannot say that this is equals to, I can solve this by saying 2 raised to power 2x plus what? 4 is equals to 2 raised to power 3. By doing this, I have made them to have the same base, isn't it? I have made them to have the same base because the indices law, indices equation law say that if I can be able to make this equation to have the same base, that their power is equal. Therefore, I cannot say that 2x plus what? 4 is equals to 3. I'll be able to make it to have the same base. Therefore, their power is equal. I'll be able to make it to have the same base without altering the equation given to me. Remember, I'll be able to make it to have the same base without altering the equation given to me. I make them to have the same base. And this is something as 8. I'm going to say the power is equal. Then by doing that, I will say that 2x is equals to 3 minus what? 4. What happened here? This plus 4. Who is one of these plus 4? When he crosses this inequality sign, when he goes out and passes through this inequality sign, cross it becomes minus because it's plus here. Crossing over here, it becomes minus. And that's how we get. Here, second example. The second example is this 2 raised to power 2x plus 4 equals to 8. Find the x. In this case, I have 2 raised to power 2x plus 4 equals to 8. Remember, in this equation tells us that if we can make both sides of this equation to have the same base, automatically their power is equal. That was demand 2. The indices equation law, the first law, said if we can make the both sides of the equation to have the same base, that automatically their power is equal. So let me see. I have this 2 raised to power 2x plus what? 4 is equals to 2 raised to power 3. I'll be able to make this section to have the same base with this without altering the equation given to me. I did not alter this 8. The 8 remain 2 raised to power 3, which we said is something as 2 raised to power 3. If I say 2 raised to power 3 is something as 2 times 2 times 2, and that's 8. And by so doing, I will have this 2x plus 4 is equals to 3. I have made this to have the same base. Automatically, the whole power here is equals to the power here. I will now have 2x is equals to 3 minus 4. How did I get minus 4? This plus 4, the owner of this plus is 4, and he is going the other way. This plus 4 going this place, crossing this equality sign, he turned to minus. Because it's plus. As he crossed this inequality sign, it turned to minus. Therefore, I'm going to have 2x is equals to minus 1. How did I get minus 1? This means I'm owing 4. I owned 4. I paid 3. I'm owing 4. I paid 3. and I'm still going to balance 1. So I have this x is equals to what? Minus 1 divided by 2. How? For me to make this x subject of formula, I have to divide 2 by 2. Dividing 2 by 2, because these 2 and x are whole together by what? Multiplication. The only way I can remove these 2 is to divide 2. I can't do what I did here in this place. I can't say 2 crossing over here. No. I can't say these 2 crossing over here. No. I can only cross over here, the inequality sign, when I'm old, when the term is whole by plus or by minus. Look at this term. Look at this term. And what combine these 2 terms is plus. And for this man to go, they have to be minus. That means association. This is what we call association. X plus y is association. That's this is my friend. That's normally said, this is my friend. This is my friend. That's why X said to his parents, this is my friend. Then this one is not my friend. But this one means this is my brother. This X said this is my brother. This one means it's not my friend. Let us learn this. This means this is my friend. This man will say this is my friend. This one means this is not my friend. It's not my friend. This one says it's not my friend. But this one is what? He is my blood brother. He is my father. He is my sister. So for you to separate my blood brother, my sister from me, you have to put asunder. So anything whole by multiplication, for you to separate it, so you to remove this one, I have to divide by x. For me to remove y, I have to divide by y. But for this, for me to remove this y, I can push it away by saying, this is not my friend, wait. This is my friend, come over. So if I have this to be equals to 0, for me to remove this man will go over here, he become what? It implies x equals to minus y. This man now, this man equals to 0, this implies, this man will be what? X equals to what? Y. This man going over here, become plus. This man going over here, he become what? Minus. This implies this man, making this man subject of formula, this man cross this inequality sign, he become minus. Because it's already plus here, going over here, become minus. Then this man is negative here, he's going over here, become plus. And I told you this one stand for is my friend, he's my friend. This one stand for is not my friend, he's not my friend. This one stand for is my blood brother, is my blood brother. If I want to make it, this is equals to, I want to remove this x, I will do xy divided by x equals to what? 0. That means I want to eliminate x here. And I will have y divided by what? X is will give me what? 0. Understood? So for me to make anything that hold together by multiplication or a subject of formula, I have to divide through. For me to make anything that hold by plus a subject of formula, I have to cross. Because when we say subject of formula, that means we are talking about equation. You can make a subject of formula in an expression. If I write this plus y, I can't say it, I want to make subject of formula. This is an expression. But when I have equals to 0, this becomes equation. It is only equation that I can make subject of formula. The only equation that we can make subject of formula. But apart from the equation, expression, we don't make subject of formula. Rather, we simplify expression. We simplify expression. We don't make subject of formula in expression. But we only make subject of formula in the word equation. I think I've made myself clear here. Plus x plus y stand for is my friend. If I want to make x subject of formula, this man have to move the other side, become minus. If I want to make this x subject of formula, this man have to move the other side, become plus. If I want to make y subject of formula here, I have to divide through by x to eliminate x. And that gives me y equals to 0. If I want to eliminate y here, I will still do the same thing by dividing by y. And that gives me 0 divided by y. That gives me what? X equals to what? 0. So what we understand here is that making subject of formula by this man become what? This is my blood brother. This is not my friend. This is my friend. I think I've cleared that. We'll come back to this. Therefore, for me to make this man subject of formula x, I have to divide through by what? 2. And I said 2 divide this will leave me with x. 2 divide minus 1 will give me minus 1 over what? 2. That gives me my x is equals to what? Minus 1 over what? 2. Then, This is indices equation. Then somebody will ask, what of if we cannot be able to make the both sides of the equation to have the same base? What of if we cannot be able to make the both sides of the equation to have the same base? What will happen? Okay, let us see. He said, if we cannot be able to make the both sides of the equation to have the same base, what will happen? We'll do this. The indices equation said, if we cannot be able to make both sides of the equation to have the same base, that we should take the log of both sides. That means I take the log of both sides. Which log of both sides? Natural log of both sides, which is log base 10. Natural log of both sides means log of base 10. Now I'm going to take it to the both sides. Let me see example here. I have 2 raised to power 2x equals to what? 3. This is also indices equation. This is indices equation. I can't be able to make these two to have the same base. There's nothing I can raise. Making the power of 2 raised to that will give me 3. I take in the base of 2 raised to that will give me 3. Is it possible? I can make these to have the same base. So therefore, I can still solve this. And how will I solve this? By taking the log of both sides. Taking the log of both sides, I have log of 2 raised to power 2x base 10 is equals to log of what? 3 base 10. And this will give me 2x log 2 base 10. And is equals to log of what? 3 base 10. Therefore, I have to make this x subject to formula. You get what I'm saying? I have to make this x subject to formula. I cannot say that, look at it, let me play this. Look at this. I cannot say that 2x is equals to log of 3 base 10 divided by log of 2 base 10. And the log of 3 in your calculator will give us, if you press this log of 3 in your calculator, it will give us something 0.030110, something like that. Not accurately. When we calculate again. So by so doing, when you get this, whatever we get this, we'll make this x subject of formula from it. We'll be able to achieve. So when we solve and we couldn't be able to make it to have the same base, we'll take the log of what? Both sides. When we solve indices equation and we couldn't be able to make it to have the same base, we'll take log of both sides. And this is where we are ending this lesson today. Subscribe to this channel, comment in the video you have watched, and share to your friends. Thank you.